In the ANOVA procedure, where we're trying to compare the population mean for multiple groups, our null hypothesis is that the mean is the same for all groups. So in this example, which we'll investigate kind of as we go through part of this section, we're looking at whether or not the average thickness in lens produced by 3 different presses is the same, or whether they need to be calibrating those machines. So our null hypothesis is that mu1 is equal to mu2 equal to mu3. In words, that says that the population mean lens thickness is the same for all 3 presses. For the alternative, we can just write that out as at least 2 of the mu1, mu2, mu3 differ, which indicates that there are some differences in the population mean lens thickness for at least 2 of the presses. What we look at then, as far as formulas go, is we calculate an F-test statistic. The 2 main things we need to calculate to get to F eventually is 2 things called sums of squares. We have a sums of squares between and a sums of squares within, indicated by SSB and SSW here. The SSB term is actually, if we think back to that motivating box plot picture, measuring like the difference from group to group, so like the middle to middle of those box plots, and getting a sense of how different they are. The SSW is measuring how spread out the groups are within them. So when we think about the box plot, like how wide is the box plot? And so we're really looking at comparing those 2 measures of spread, or these 2 sums of squares. In addition to those 2 formulas, which is the bulk of the work, we have 2 degrees of freedom between and degrees of freedom within, which are k minus 1 and n minus k, so they're whole numbers. K is the number of groups, n is the total amount of data you have. We take our sums of squares, divide by the degrees of freedom, and we call those mean squares. So we have MSB and MSW. Finally, the ratio of those 2 mean squares gives us this F, which is our test statistic. We will look that F up in an F distribution in StatKey, which uses these 2 degrees of freedom, and then we'll always look in the right tail to get our p-value. One other thing to note here about the formulas is within SSB, these X's with the subscripts 1, 2, etc. are the means for the individual groups, but we also have this X bar without a subscript. That is this formula here, which is the overall or the grand mean, and that is the mean of all the data. You can obtain the mean of all the data by actually going back and multiplying your individual means by their sample sizes, adding them up, and then dividing by the total amount of data. In the formula for SSW, we have S1, S2 out to SK, and they are squared. So those are individual standard deviations being squared. In the next video, then we'll actually look at the data and plug things in and calculate these.